Okay, our second lesson deals with quadratic equations. So let's start with a couple of terms and just general vocabulary ideas. A quadratic equation in standard form is ax squared plus bx plus c equals 0. So in other words, we have all of the terms on the left side, it's equal 0 on the right. We've combined like terms so that we just have a squared term, an x term, and a constant term that we're dealing with. In this section, we're going to look at four main methods of solving quadratic equations. And then we'll look at when it's most convenient to use each method. All right, so what are the four methods? We're going to look at factoring. We're going to look at the square root method. We're going to look at a process called completing the square. And then we're going to look at the quadratic formula. All right, now. Okay, now some of these methods require a lot of things to look out for, a lot of details. Factoring is the one that I happen to think is the easiest to use, and if it works, it speeds the process up and just makes the problem a lot quicker to get to the answer. And so when would you want to use factoring? Well, I'm going to go ahead and say always try it. Always try to use first. And the only reason why you'd abandon ship and go on to something else is if you can't see how to factor the expression. In order to use the factoring method, we want to first put it into standard form. And remember, that's with the left side as an expression, and it happens to equal 0 on the right. Then we want to factor, and that's pretty, I'll go through some examples, but if you're still struggling with factoring, that would be something that I would email me directly and ask for more tutorial and resources on factoring processes. And then our third step in this process is to utilize the zero product property. And the zero product property simply says that either A happens to be 0 or B happens to be 0. So if I have a product of two things, and I know the product is equivalent to a 0, then that means each of the individual expressions have to be equivalent to 0. Okay, so let's look at some examples. Okay, so in this first problem, I'm going to look for, let's see, so my goal in factoring is I want it to look like this, right? So I want to look at that first position, and that first position is based off this 2x squared. Well, how do you get 2x squared when you're multiplying? Well, it's got to be 2x times x, or x times 2x, and that's pretty much about it. Those are your only two options to see that. So that one's pretty straightforward. I can go ahead and put in, well, I'll make one of them 2x and one of them x. Now this other part, where does it come from? And I'm just going to play with some colors here for a second. So where does this, if I can factor it, where do I see that number from? And that comes from the 12, the negative 12. And so I'm just going to think for a second. What are some numbers that I can multiply to get negative 12? Well, I can do negative 1 and 12. I can do negative 2 and 6. I can do negative 3 and 4. What else we got? And I can switch those around, so I can have 12 and negative 1, or I can have 2 and negative, I'm sorry, when I said 12 and negative 1, I meant negative 12 and 1. And then I can have negative 6 and 2, and I can have negative 4 and 3. And that's pretty much as far as my combos go. One technique that I liked when I played around with factoring was to just guess and check. So I've got 3 different combinations, and I got 2 different places I can stick things. I know it's going to be 2 times something, so I'm going to have to double it. So I'm looking for, if I double one of these numbers and then add it to the other, can I get a 5, a negative 5 out of that? And let's see, so if I double a 2, so I double 1, I get 2. Well, 2 and 12, there's no way to get a 5 there. And if I double the 12, I get 24 and 1. That's not a 5. Here, if I double the 2, I get a 4 and a 6. No. Double 6, 12, and 2. No. Double the 3, I get 6 and 4. No. But if I double the 4, I get 8. 8 and 3. 8 and 3 does give me 5. So it looks like 4 and 3 are my winners. And I want the negative, so I want it to be negative 8. So I want that to be a negative 4, and I want that to be a positive 3. And one way to just double check that we didn't mess this up is just to refoil it. So let me go back to my other previous, let me go to blue, why not? So if I refoil this real quick, I get 2x squared minus 8x plus 3x minus 12, and when I combine like terms, does that give me the original 5x? It does. So we know that we have set this up correctly. Okay, so the correct factored form is 2x plus 3 and x minus 4. Okay, so according to the zero product property then, I can take that expression equal to the 2x plus 3 and set it equal to 0. And then I can take the x minus 4 and set it equal to 0. Okay, well the 2x plus 3, I want to bring that 3 over. And so I get negative 3 halves. And here I want to bring the 4 over, and I get 4. So our solution set, because you'll see that on the homework, is a collection of numbers. So we have 2 numbers that satisfy this equation, and that would be negative 3 halves and 4. So you'll see it with that set notation. All right, in this next example, again, we're doing solving by factoring. I got 5x squared minus 20, and one of our factoring techniques is to look for GCF, a greatest common factor. So I happen to see that I can take a 5 out of both terms. So I can factor out a 5, so that's x squared minus 4 equals 0. And then from here, let's see, x squared minus 4 is one of our difference of two squares formulas. So that's x minus 2 and x plus 2. And then I'm going to set each factor equal to 0. Now, just a quick note, if I take 5 equals, does that make any sense to say 5 equals 0? Not really. But I can set x minus 2 equal to 0 and x plus 2 equal to 0. And so when I solve for that, so I'm going to add 2 to both sides. I end up getting positive 2 for an answer and negative 2 for an answer. So in set notation, there are my 2 solutions. Okay, and in this third example, we don't have it in standard form. So that's my initial goal, is to get it into standard form by putting all the appropriate terms on the left side here. So I'm going to go ahead and subtract off 3x from both sides, and I'm going to add 1 to both sides. And so I end up with the expression 4x squared minus 12x plus 9 equals 0. Okay. And so then I'm going to do that whole guess and check factoring thing. And in this first position, let's see, it's based on the 4. Well, the 4 is either a 2 and a 2 or a 1 and 4. It's pretty much the only combination that'll ever work that out. And in the end position, we have a 1 and 1 and 9, or 3 and 3 is the only way to end up getting 9. And I want to end up with a negative 12 in the middle there. Well, one other thing I notice is I've got a positive 9 at the end. So that means either both numbers were positive to start off with in the factored form, or they're both negative. So with that minus 12 there means they've got to be both negative somehow. Well, let's just kind of guess. Let's try the 2x. So let's try 2x minus something and 2x minus something. Okay, so that means if I've got 2's in both places, I'm going to multiply it by the other number, and when I multiply and then add, I should end up with a 12. So I can just kind of in my head, I can double this. So if I double 1 and double 9, does that give me 12? Nope. If I double 1, I get a 2 and an 18. 2 and 18, there's no way I can get a 12 out of that. If I double the 3's, I get 6's, and 6 and 6, I can get 12 out of that. So I want 2x minus 3 for both of those. Okay, and so the fact that I got the same factor is fine. There's no sense to solve, there's no sense to solve twice to get the same answer twice. That does mean something that we'll talk about later on. But I can just set the 2x minus 3 equal to 0 and then solve. So I'm going to bring the 3 over, so 2x equals 3, and then x would be 3 halves. So that would be our single solution is 3 halves. All right, our second method is called the square root method, or in fancier terms, it's the extraction of roots method. We use this method when the equation's in the format of some sort of expression squared equals some sort of number. Okay. Now notice what's missing in this, if we're thinking about standard form. We're missing the linear term, or that b term from the standard form. In other words, b equals 0. And when that happens, then it's easy to put it in this form. Okay, so the steps for doing the square root method is put the quadratic equation in the form where the expression is squared equals some number, some constant. Then we're going to take the square root of both sides and solve. And notice when you take the square root of both sides that we must do a plus or minus on both of the numerical part. So on the right side we'll end up with a plus or minus of some kind. Okay, so our first example, 5x squared equals 9. So notice we can easily isolate the squared term. So I'm going to divide both sides by 5 and get x squared equals 9/5. And then I'm going to take the square root of both sides. So when I do that, on the left side I end up with x, but remember we get plus or minus the square root of 9/5. And I don't want it to make, I don't want you to, you gotta be careful with extending out that square root. So I don't want you to think that the square root only applies to the numerator. It actually doesn't. Now, this is sort of an interesting conversation then, depending upon how much exposure you've had to this. Technically speaking, we are not allowed to leave a square root in the denominator. We need to do something about it. So we end up with at least a whole number. The process is called rationalizing the denominator. But let's talk about that 9 for a second, then we'll talk about the 5. What is the square root of 9? Well, that happens to be 3. Okay. And so rationalizing the denominator, what we end up doing is we end up just multiplying that square root of 5 by the square root of 5. But I can't just multiply one piece. I have to multiply everything by that. Now that piece right there, that's just equal to the number 1. So that's why I can justify that I can multiply by 1. And then typically whatever's in the denominator, that's what we multiply by. And so we end up with plus or minus 3 times the square root of 5 over 5 as our final answer there. Okay. This next example, 3x plus 1 squared equals -9. So we start off with that. Now, just a word of caution, we're taking the square root of a negative. We're actually going to, in a quick lesson, we're going to review imaginary numbers and how the rules on those work. But I think we've seen enough square roots and negatives that we can square root of -9. We happen to know what that is. So when I take the square root of the left, I get 3x plus 1. On the right, I get plus or minus 3i, because I took the square root of that negative. And so then I want to solve for x. I want to subtract the 1 off. And then I want to divide both sides by 3. So I get x equals, and then I'll split that up. So -1/3 plus or minus 3 over 3i. Now that 3 over 3 we can reduce. So -1/3 plus or minus I is our final answer. Perfectly fine answer. All right, last one. Well, we've got a square. We don't have a linear term, so we're missing that bx term. So it's kind of the dead giveaway that we're dealing with completing the square. So I'm going to subtract off the 3. So 11 minus 3 gives me 8. And then I'm going to divide by 2. And 8 divided by 2 happens to be 4. And then I can apply the square root method. So sometimes it takes a little bit more steps to get there. So on the left side, I have 2x plus 1. And on the right side, I have plus or minus 2. All right, so then I'm going to subtract off the 1. And then divide by 2 there, so -1 plus or minus 2 over 2. Now I can actually split that up and I can get actual answers for that, since the -1 and the 2 do combine. So what is that? That's 1/2 and -3/2 are our final answers. I'm sorry, positive 1/2. And those are perfectly good answers.